In this video, we will use the sine function to differentiate the Maclaurin series from Taylor series, centered at 0 to 6. So data validation, list of items, 0 to 6. We can start from 0 because Taylor series centered at 0 is Maclaurin series. Now we generate the data set of sine. So RA formula, sine of the x values. Now the Maclaurin series, which is the summation of a times x to the power 2n plus 1, where the value of n is from 0 to infinity. 17 is good enough. And the value of a is the coefficient negative, this is RA formula, minus 1 raised to the power n, divided by, that is, the denominator is factorial 2n plus 1, so factorial 2 times n plus 1, then enter. Now we can complete the Maclaurin series dataset. So RA formula, series sum of the x values raised to the power 2n plus 1, where 2n plus 1 starts from 1, incremented by 2. So at n equals 0, it's 1, n equals 1, 2 plus 1, 3, so 1, 3, 5, 7, 9, so the interval is 2. And the coefficient, a will be this range. Continue with the Taylor series, which is the summation of b times x minus theta raised to the power n, where the value of b is, again, RA formula, sine 0.5 times pi times n. Okay, 0.5 pi times n plus theta. That's for the numerator. Now the denominator. The denominator will be divided by, that is, factorial n. Factorial of n. Now we can complete the Maclaurin series expansion. So RA formula, series sum of the, this is x minus theta. So x minus theta raised to the power n, where n starts from 0 up to infinity. So 1 starts from 0, incremented by 1. And the coefficient will be this range. And we'll chart this. Insert chart. And we use scatter chart. We don't need a title. We need a space. And use column A as label. And we show the trend line. So series, check the trend line. The type will be polynomial. The degree 6. For the label, use the equation. For the legend, position at the bottom. So here's the trend line. They're all collinear, and the polynomials of cosine, both in the Taylor series and the Maclaurin series expansion. We calculate this polynomial regression coefficient using Linus. To do that, we complete the Linus matrix, starting with the power. This is transpose 0 to 6. And the elements of the matrix, RA formula of the x values raised to the power 0 to 6. Now we can use Linus. Linus data y and data x. This will be also Linus data y comma, and data x. And the Taylor series, linest, data y, comma, and data x. And let's compare. So right now the Taylor series is centered at 0, so it's the same as the Maclaurin series. So coefficient of x to the 0, 0. Coefficient of this is 0, 10 times negative exponent negative 31, that's very, very small. Coefficient of x, 0.904, 0.903. Coefficient of x squared, 0.225, 0.227. Coefficient of x cubed, minus 0.358, minus 0.359. Coefficient of x to the fourth, 0.0732, so 0.0736. Coefficient of x to the fifth, negative 3.13 times 10 to the minus 13, minus 3, 3.2 times 10 to the minus 3. Coefficient of x to the sixth, 1.52 times 10 to the minus 4, negative 1.47 times 10 to the minus 4. So there's an error here, negative 1.52 against negative 1.47. Now we center this at 1. They're now exactly the same, and their data sets remain the same, and their lines are still collinear. Center this at 2. There's still no change, they're exactly the same. Their polynomials, their data sets are the same, their polynomials still the same, and they're still collinear. Center this at 3. There's still no change. The polynomial regression coefficients are still the same, and this still approximates the sine function. Center this at 4. Theta equals 4. Still the same. Now they're exactly the same. This Maclaurin series and Taylor series are exactly the same. They're also the same here. Center this at 5. Still no change. Their polynomial regression coefficients are still the same. Data sets are also the same. Now they're exactly the same. And their trend lines are the same. Center this at 6. There's no change. There's now a slight error here in the Taylor series. So this completes the use of series sum function linus polynomial regression to show the trend line of sine and its Maclaurin series and the Taylor series centered from 0 to 6.